So the first thing you'll see when the computer boots up is this screen. You have these three icons on the left side, and that shows All View, All Log, and Monitor. And these programs, All View, All Log, and Monitor, from the top down, All View is the Retort's remote control software. That's going to be the software that controls the retort. You can't do anything on the retort without using All View. All Log software is what captures all the data from the machine. It needs to be running in the background, otherwise it won't capture any of the batch data or the records from the retort after it runs every process. And then you have the monitor software. The monitor software is what you use to create recipes for the machine. That's where you schedule recipes for your machine, create users, all the administrative side of running the machine, that's in the monitor software. So when you turn the computer on, it should automatically boot up All Log, and you'll see it running. It'll just show like a little do not close window, and then you can just go ahead and minimize it to the system tray, and you'll find it's a little floppy disk in the bottom. And then I can run All View, and that'll boot up real quick and you can see it. So starting from the top left, working my way down, you see the two stoplights at the top of the screen, and they both show green on both stoplights. The one on the top left refers to the All View, the laptop's connection to the controller in the machine, and the one on the top right refers to the All Log program being open. So if I were to go ahead and close this All Log program right now, it would no longer be logging data from the machine's controller, and if you give it a minute or two, that little stoplight will turn red. The machine will make an alarm to inform you of that problem. So right now the machine's shut down and in an e-stop state, and I'll show you how to get out of that in just a second. But as we move down, so you have your basic status information directly under the stoplights. You have your date time, you have your segment time, segment data, and batch data. So what segment time is when you create a recipe, each recipe is made up of multiple blocks. You have your initial come up fill where you fill up with water, you have your come up where you bring that water up to temperature, you have your cook where you maintain stability and temperature and pressure and just hold your product at that. So the segment time refers to which step in your recipe you're currently in. Elapsed will refer to how long you've currently been in that step. Schedule will be how long you've made that step in the recipe. So for instance, if you're in a cooling step, it's not going to leave that segment until it meets the temperatures you specified in your recipe. But if it doesn't meet those parameters, it will go over the time. So you'll see something like if you scheduled 5 minutes, we haven't met that temperature in the 5 minutes, you'll see something like 5 minutes, 30 seconds there in the elapsed time. Directly to the right of that is segment data. So it says step description, which is the step the machine's currently in, and segment. So you can have multiple segments of the exact same step in a recipe. So if you want different temperature profiles or pressure profiles and come-ups, you can have 3 different types of come-ups in a row. So in your step description, each one of those would still say come up, but you'd have to look to the segment number to see which come up you're currently in. As it is now, because the machine's in shutdown, shutdown's not a real recipe step that you can schedule, so it's just going to show dashed lines. Batch data is currently showing batch 8, just because I've run 8 processes so far with the machine for the past 2 days. Typically that resets at midnight. Recipe code, recipe code shows the recipe name you set for this recipe. It's whatever you decide it to be. And then directly to the right, that is process type. So this machine can run, I believe, 5 types of processes. You have water spray, full water immersion, steam process with a spray cool, steam process with a flood cool, and a sterilmatic sim process. I'll get into detail when I make recipes later on, but for now, those are the processes this can run, and you'll see which was the last type of process currently scheduled in the machine in the process type window. Below that menu is the process, and there's that host communication failure alarm that I talked about earlier. You could see in the top right that stoplights turn red, and that means this software is no longer recording any data from the machine. So if I rerun the All Log software, it'll boot up, I can minimize it, and you see the stoplight has already turned green again. The machine will run with that software turned off, but it will not run if the stoplight on the left is red. So if the stoplight on the left is red, that means either there's been some sort of failure in the AllView program, or there's been some sort of Ethernet communication failure, so something in your network is not talking from this computer to the controller. If this stoplight ever turns red, you can either check to make sure the all-log program is turned off, or it's turned on. You can restart the program, make sure that turns green before you resume testing. So directly underneath, you have the status menus. You have the process vessel status and the storage vessel status. So in the process vessel status, it shows temperature, pressure, level, and RPM. These are all the analog inputs on the process vessel. You see the PV column, the SP column, and the CV column. So the PV is the process vessel's, for instance, it's its current value. So it's currently reading 81 degrees inside the vessel. It's currently reading 0 PSI in the vessel. It has no water level detected in the vessel, and obviously it's not rotating, so it's getting an RPM of 0. The SP column is the set point. So if, for instance, the machine's trying to get to 210 degrees, it's currently at 190 degrees. You'll see the 190 degrees in the process vessel column. You'll see that set point of 210 degrees in that column. And the CV refers to the percentage of a valve that's currently open that's associated with that. So if it's trying to heat up, the CV will refer to the percentage the steam valve is open. So if you see, you know, again in that example, if it's trying to meet 210 degrees, it's at 195 degrees, and that last value shows 60. That means the steam valve is 60% open to meet the 210 degrees. If it goes to a cooling step, the CV will refer to the valve that's currently cooling the machine. So in that case, it will refer to the heat exchanger cooling water valve. I'll show you where that is later. The level on the machine, so on the process vessel on this machine, it does have analog level. So it's a, you know, pretty simple 0 to 100 percentage of how full is the machine. In certain steps like the water immersion, where you expect it to fill all the way up, it's not going to show filling all the way up to 100%. It's going to show it filling up to 85, 80, 90%. It's going to fill up enough to cover your product with water, but not all the way up to the top of the vessel. So just keep that in mind. Directly to the right of that is a storage vessel. The storage vessel only has temperature probes in it. It doesn't detect pressure. It doesn't have any analog level feedback. What it does have, when you see in the level sight glass, it has a single proximity sensor at the point where it's filled up as much as it needs to be on the storage tank. Once that proximity sensor is met, and if I walk over and flag it, you'll see the storage vessel level has filled up all the way. So if I take my hand away, it's all the way emptied out.
Do
So
that again? Where does it show that?
on the
right
storage
here.
tank,
Okay, I got it.
it shows up filled all the way up with blue. That's not the storage tank is filling to 100% and emptying out completely. It's just that proximity sensor is being flagged off and on. So directly to the right of that is the message center. So the message center is pretty much one of the most important places to look when you're running the machine. This top black box, the message box, that will tell you what the machine is currently trying to accomplish or what you need to do to get to move the machine to the next step. So right now it's in an e-stop state, and it's saying emergency stop, pull out e-stop button and reset. So the e-stop button's already been pulled out, so all I have to do to get the machine back running is to click the e-stop reset button. Directly underneath that, you see the analog and discrete menus. That refers to the analog and discrete valves are all in auto mode. If I have the appropriate administrative privileges, I can go to a specific valve on the menu, override what state it's supposed to be in. For instance, if I was performing maintenance on the machine, or if I knew enough about the machine to make it do what I wanted, if, for instance, something went wrong with the machine, you had to shut it down, and now you have a bunch of air pressure in the line. 9 times out of 10, you would override the machine into the drain state, let it deal with the air pressure inside the machine on its own. But if you wanted to, you could override into the specific vent valve you wanted and open the vent valve to relieve that pressure. Like I said, 9 times out of 10, you want to override the machine to the appropriate state and let it do what it wants. But if you do, for instance, go into the valve menu and override a certain valve, you'll see it changes states in the analog or discrete menu. So just for example, I'll go to the analog valve menu. I'll go to the process BPR and I'll change it to auto. It will ask me for a password. It will alarm when I change state, and now it's changed from auto to manual. And if I go back to that main menu, you'll see I have an analog output label as manual now. The machine won't start a process if any valves are in a manual state. They all have to be in their auto state. So if I go back to that menu, click on manual again, you'll see that's gone back to auto mode. It works the same way for the discrete valves. Directly underneath that is the alarms menu. So typically it will say none in green letters with a black background. Because the machine's in an e-stop state, we currently have an alarm state in the machine. So it's got a yellow background. In red letters it shows alarm. If I go to my alarm menu on the right, I can click alarm summary, and it will tell me everything that's currently an issue in the machine. So it says safety emergency stop. I need to reset via the HMI. It's telling me the motor control panel disconnect is open. So that disconnect on the panel, which I'll show you how when I reset the state in a second. And we're in a safety shutdown with emergency stop. So directly underneath that is the status. The status refers to the integrity of your current batch. So if when you're running a process, if for instance the boiler goes out, you lose steam, something happens where maybe a valve breaks and the machine overflows with water, you get more water in the machine than the process would allow, the process would be considered deviated, and that just means your recipe didn't go as intended. Either there was a drop in temperature, there was too much water in the vessel, something happened to basically corrupt your product, and it will consider the batch deviated. When that happens, there will be a flashing symbol up here that just says deviated in red letters, and in the status menu it will say unclear deviation. You can have a clear deviation if, for instance, you have a temperature drop of some sort when you're running a process. You can specify an alternate cook step, where if you're in your cook step and you have a temperature drop, for instance, if you know you need to cook at 250 degrees for 20 minutes or 248 degrees for 25 minutes, something like that, you can specify an alternate cook step, and if it drops to the temperature associated with your alternate cook, it will just jump directly into that step, and that's considered a clear deviation, and your batch, your product is considered untainted. And lastly, the step exit. So if you're running a step, it will tell you there what parameters need to be met for that step to continue. So for instance, in a come up fill step, you need to fill the vessel with water, and that's it. So it will just say level in the step exit. During a come up step, for instance, you probably need to bring the vessel up to a particular temperature and bring the vessel up to a particular pressure. So there it will say temperature and pressure. If you have the step, for instance, like a cook step, it just needs to last a certain amount of time at your temperature and pressure before moving on. So it will just say time there. So the most useful troubleshooting tools on this machine are the message center right here, this message box, and the step exit. If the machine's ever doing something it needs to not be doing, or you don't know why it's moving on to the next step, check those, and 9 times out of 10 they'll tell you exactly what it's trying to do and why it hasn't got there. Directly to the right of that, you have the operator actions menu. So these buttons will appear and disappear whenever they're needed, but the shutdown and log on, log off button will always exist. Now, most operator interactions require an operator with the correct administrator privileges to be logged in. Now the machine's in the e-stop state, so it's given me the button to reset the e-stop state. So right now, I'll just go ahead, click that. Now the e-stop state's been reset, and you can see if I go to my alarm summaries, all those related e-stop alarms have disappeared. The only thing that's left is the motor disconnect step, and I'll get on that in a second. Now we have 4 submenus at the bottom of the screen. We have the trend submenu, which tracks temperature and pressure over time as you run your process. This doesn't interface with the Caltech probes. These are just what our probes in the process vessel detect. So they're not, again, they're not as accurate as a Caltech probes and what it's currently happening inside your product, but it's what's currently happening inside the vessel. They also have the temperature and pressure set points that you've associated with this recipe in the graph as well, so you can see how well the machine is currently tracking against those set points. Directly underneath that is your recipe menu. As you begin running your recipe, you have the recipe you're currently running displayed in this recipe menu. It will be highlighted which step you're in a gray bar at the bottom, and you have all your recipe set points currently on display there. Directly underneath that is the status menu. So you have some redundant information here with your analog inputs. You have all the analog inputs at this bottom point, as well as you can see up here, but you also have access to see your digital inputs. Again, this is more of a maintenance tool than anything else, but all of your discrete inputs, which are simple on and off proximity switches, that sort of thing, you'll see them check marked off if they're currently made. It's an empty box if they're not currently made. So for instance, you keep closing the door and it says the door isn't closed when you go to start a process. You can look here and see, okay, does it say door closed when I'm actually closing the door? If not, maybe there's something wrong with that proximity sensor. Again, it's more of a troubleshooting tool than anything else. And directly underneath that, you have your device menu. So this is if you ever need to manually control the rotor, this is where you would go to do it. It's pretty simple, just jog forward, jog reverse, or home. So if you ever need to manually home the rotor, you open the door up, for some reason it hasn't homed itself, you close the door, you hit the home button, it will go ahead and home itself. You can't run the rotor with the door open. That might be a safety risk, just saying. So if we go to our screens on the right, first I'll show you the two analog, the analog and analog and discrete output menus. So just as an example, I showed you earlier that if I were to change the process BPR from auto to manual, it gives you a little alarm. It'll change the state of the machine so it won't start a process now. So you see set point, process vessel, and the CV, which I believe is the current value. So on a BPR, so you can see it's giving 60% of a signal to the BPR, so the BPR is going to, the way the BPR works is it's going to hold up to 60 psi in the vessel if it's 60% open. You see you have this little grid box at the bottom, and then you have a little graph box. So if you need to manually adjust the value of an analog output, you would change the PID from auto to manual, and then you would select the little calculator grid box thing. And so now I say I want it at 20. And now the valve has changed state from 60% to 20%. The PV for the process BPR will refer to the pressure in the vessel. Currently you see we're at 0 psi. On the steam valve, it's going to refer to, obviously, the temperature of the vessel. Same thing with the water valve. It will also refer to the temperature in the vessel. The storage BPR refers to the temperature in the storage tank. Process overpressure refers to the PSI in the main tank. Now you see these little colorful graph buttons. These are tuning for the valves 90% of the time. 99% of the time, this is just for us to tune the machine as we run a process. You can adjust tuning parameters through this by adjusting the integral for each step, but I would say it's not something you want to be touching too often. If you do ever tune it, I'll show you how you can reset the default tuning parameters for a recipe in the recipe menu. So in your recipe menu, you can see all the recipes you currently have available in the machine. These are all recipes currently assigned to the machine, not all recipes currently made in the software. You can see the different steps of your current recipe, but if you go to tuning, you can select which step you accidentally changed the tuning parameter in. So if we accidentally messed with the steam valve in the shutdown state, we can just click default. It will reset everything associated with the steam valve to default. We've already gone into the alarm summary menu a bit, but you can see, so here's our current alarms, and the alarms are divided into current and unacknowledged. So whenever the banner pops up at the bottom, to get rid of the banner, there's a button that says acknowledge. So if I go ahead and trigger an alarm right now by changing something into manual, so now I've changed the red beacon light to manual mode, so I can now have control whether it's on or off. But if I go to the alarm summary screen, you can see I have a new alarm there. So if I were to return to that screen, put that in manual, then put it in auto, then put it in manual again, I haven't acknowledged this. So if I go to my alarm summary screen and go to my unacknowledged, it's listed in the unacknowledged alarm. So it was an alarm that popped up, but no one clicked the button that said they saw it. So if you have an issue and you want to know if anyone said they saw the alarm, that's what that's for. It's more of a tool for production machines than in an R&D environment, but it still carries over. So you can acknowledge the alarm from this menu. Now the alarm's been acknowledged. Hey, I saw it, and it will log who was logged in at the time and who said they saw the alarm. So in my case, it will say Joe Regard acknowledged that they saw this alarm. So if I turn this back to auto, you'll see it disappeared. You also have access to the alarm history, which shows all the alarms that have happened over the past month or so. You can set the start date, end date at the bottom if you needed to see past that. Directly underneath that is the process record, so that will show the preview of the batch report from the last process the machine ran. It will show all the recipe milestones, such as temperature made, level made, when you're running the process. It's just a simplified version of the report in the administrative monitor software that you'll see later, but if you need to see it here, that's where you would see it. And that's pretty much everything in this software. There are a few other little things, so I'll try and show you that in a bit. But if your all-log recording software ever fails while the machine is running, if it hasn't been started up by the time you're ready to start a new recipe, it will give you a button in the operator action window that says something along the lines of made written record. If you ever see that button appear, that's the software telling you it hasn't captured all the data 100% correctly, and it's having you acknowledge, hey, I've made a written record. I acknowledge that the capture software hasn't fully captured all the data. Now the last menu at the top is the system overrides menu, and this allows you to jump to the different steps in a recipe. So for instance, if you've come in, you're ready to run your first cook of the day, the machine's been completely powered off. If the machine is in a shutdown state, the first thing you want to do is override to the prepare to process state. So the machine has all your recipe states on the left that are associated with your recipe, and on the right, your machine has all of the states that aren't strictly associated with the recipe and not something you can schedule. So you have shutdown, which is pretty self-explanatory. The machine is shut down. You have prepare to process. Then you have drain, unload, and purge. Prepare to process puts the machine in a state where it's ready to accept recipes. So the first thing, if you want to turn the machine on, is you turn your utilities on, you put the machine in prepare to process step, and you put your recipe into the machine. You're good to run. Directly under that is drain. What that will do is that will reduce the pressure in the machine to 5 psi. If there's no pressure in the vessel, it'll bring it up to 5 psi. And all it will do is just pump all the water in the vessel, in the process vessel, down the drain. Under that is unload. Unload is a process very similar. It's a state very similar to a shutdown state. The machine's not doing anything. It might be doing storage preparation if you ran a process that requires it. It will try and prepare itself, assuming you're running the same process again, and will begin preparing the storage tank. But other than that, it won't be doing anything in the process vessel, and once you open the door, it will move to the prepare to process step again. And directly underneath that is the purge step. The purge step is to clear the storage tank of any water. So what it will do is it will add a bunch of pressure to the storage tank, pump all that water into the process tank, and then drain the process tank. So that if you aren't planning on running the machine for a while, the machine is going to sit here for a month or two, you're going to want to get rid of the water in the storage tank so it doesn't stagnate, cause a mess. So you can just run the purge step. It will empty out both tanks of pressure and water. So it's good to sit there for a while.
What's a while?
What's that?
What's a while?
Typically you want to run the machine once a month.
Once a month.
So if you're not going to run the machine for a week or two, I would say purge the machine.
I had a question about the segment you were talking about.
Yeah.
So a lot of times, I know you said recipe, but let's just say like in our teaching examples, we'll have different pans with different products in it.
Sure.
So we're trying to have our thermocouples in the pan reach a certain point, and for pan spinach, it's a take longer than for our peas, for instance, or something like that. So is there a way to like real time deviate from the recipe, or
So if you mean if you want to see your cook, so okay, I understand what you're saying. So if your one product needs to reach the temperature and your other product's already reached it, and you think your recipe isn't going to make the cook last long enough,
yes.
When you're running a process, which I'll show you in a second, every single step has a pause button associated with it. It will pop up in the operator actions menu. If you want to say, okay, I want this cook to go 2 more minutes, you can press the pause button, and what it will do is it will keep the machine from progressing to the next step in the recipe until you unlock the pause button.
When you do that, the clock keeps running.
The clock keeps running.
On the screen, it almost looks like nothing has changed, even though the pause button is pressed.
Right.
It'll just keep you from advancing to the next stage.
Correct.
And instead of pausing, could you, let's say you reach your temperature faster than you expected, could you like go skip ahead?
Yes, that's what you would use the system overrides menu for.
System override, okay.
So if I wanted to extend the cook, sorry.
No, no problem.
If I wanted to extend the cook, say my come out time was a little shorter than what my validated process says it should be, and I wanted to increase my cook time by about 30 seconds, I have to push the pause and leave it pressed for 30 seconds past the normal end of the cook cycle. I can't just push it for 30 seconds during the middle of the cook cycle, release it again, and have it add 30 seconds.
Correct. So you need to have it, you can click the pause button at any point during the recipe, but once you let off the pause button, it will advance to the next segment. Anything else? So there are a few more features of the software that I'll get into once we're actually running a process, but next I'm going to run through the monitor software. So one last thing, if you ever need to close the program to restart it, something like that, it's a Control, Shift, and a click on the Allpax button, and the program closes.